in addition to system memory management and software program management, it also takes care of hardware management and then file system management. So now let's look into hardware management. So in hardware management, still another responsibility for the kernel is hardware management. So any device that Linux system must communicate with needs driver code inserted inside the kernel code. The driver code allows the kernel to uh, pass data back and forth to the device, acting as a middleman between applications and the hardware. So fundamentally, there are two methods that are used for inserting device driver code in the Linux kernel. The first one is drivers compiled in the kernel. That's the one way. Second one is driver module added to the kernel. These are the two methods the kernel uses normally. The Linux system identifies hardware devices as a special files. That's what the most important uh, concept to be put in your mind about Linux is uh, everything in Linux is a file. Everything in Linux is a file. So the Linux system identifies even hardware devices as a special files called device files. These are the classifications of device files. First one is character. Character device files are for devices that can only handle data one character at a time. So most types of modems and terminals are created as character files. Block files are for devices that can handle data in large blocks at a time, such as disk drives. Now the second one is block. The network file type block is the one which is network file type are used for devices that use packets to send and receive data. This includes network cards and a special loopback device that allows the Linux system to communicate with itself using common network programming protocols. Then the third one what we have is a node or network. So Linux creates a special files called nodes, nodes, nodes for each device on the system. All communication with the device is performed through the device node. So each node has a unique number pair that identifies it to the Linux kernel. And the last one of the last function of the Linux kernel is the file system management. So unlike some other operating systems, the Linux kernel can support different types of file systems to read and write data to and from hard drives. So, besides having over a dozen file systems of its own, Linux can read and write to and from the file systems used by the other operating systems as such as Microsoft Windows. If you see the examples that I have mentioned on the screen, ext, ex3, ex4, these are Linux extended file systems. These are fundamental and widely used in Linux. So these are called the original Linux file system, that ext, ext2, ext3, ext4. Whereas NTFS, NTFS. So this is for the to support for Microsoft NT file system. What is Microsoft NT? Microsoft NT is a kernel for the Windows. Then proc, access to the system information, and MS-DOS, Microsoft FAT16. These are all different file systems that can be supported by the Linux kernel. So any hard drive that a Linux server accesses must be formatted using one of the file system types that I've just mentioned. So now from Linux kernel, we will move on to GNU utilities. So besides having a kernel to control hard drives, a computer operating system needs utilities to perform standard functions such as controlling files and programs. While Linus while Linus Torvald created the Linux system kernel, he had no system utilities to run on it. Fortunately for him, at the same time he was working, a group of people were working together on the internet, trying to develop a standard set of computer system utilities that mimic the popular Unix operating system UNIX. That was the popular operating system during these days when Linus was working on Linux. So the GNU organization, don't worry, I will tell what is GNU. GNU is nothing but GNU stands for GNU's not Unix. That's, it seems little weird, but that's what it is. GNU means GNU is not Unix. So developed a complete set of Unix utilities but had no kernel system to run them on. So Linus has developed Linux kernel, whereas GNU organization has developed a complete set of Unix utilities but had no kernel. So now these two things should be married. So these utilities were developed under a software philosophy called open source software, that is OSS, while the bundling of the Linux kernel and the GNU utilities is often just called as Linux. After marry happened between Linux kernel and GNU utilities, the output that has come out is called as Linux or Linux. You will see some Linux purists on the internet refer to it as a GNU Linux system. So in spite of just calling it as a Linux, because Linux that doesn't take the contributions that were done by the GNU organization. So that's why many of the Linux purists they refer Linux as GNU Linux system to give complete to give at least some amount of credit to the GNU organization for its contributions to the cause. So if you look into the core GNU utilities, the GNU project was mainly designed for Unix system administrators to have a Unix like environment available. This focus resulted in the project porting many common Unix system command line utilities. The core bundle of utilities supplied to the Linux system is called core utils package. Core utils package, that is COREUTILS. Core utils package. So the GNU core utils package consists of three parts. The first one is utilities for handling files, and second one is utilities for manipulating text, and the third one is utilities for managing processes. So the next we are going to look into is one of the utilities of such kind, that is the Linux shell or GNU Linux shell. The GNU Linux shell is a special interactive utility. It provides a way for users to start programs, manage files on the file system, and manage processes running on the Linux system. The core of the shell is the command prompt. The core of this shell is command prompt. The command prompt is the interactive part of the shell. It allows you to enter text commands and then it interprets the commands and executes them in the kernel. The shell contains a set of internal commands that you use to control uh, things such as copying files, moving files, renaming files, and displaying the programs currently running on the system. And stopping the programs also running on the system. Besides the internal commands. The shell also allows to enter the name of a program at the command prompt. The shell passes the program name of to the kernel to start it. So you can also group shell commands into files to execute as a program. Those files are called shell scripts that we are going to look into the shell scripts in next part of this module. We are going to deep dive into the shell scripts. This shell scripts provides great flexibility in creating utilities for commonly run commands or processes that require several commands grouped together. So now we will look into the bash shell of the utilities. So as we discussed in the previous slide, the default shell used in all Linux distributions is the bash shell. The bash shell was developed by the GNU project as a replacement for the standard Unix shell called the Borny shell after its creator. It was named based on after its creator, Borny. So the bash shell, the bash shell name is a play on the wording. It refers to the Borny again shell. That's what the bash means. Bash, BASH, means Borny, B again shell, SH. So we can see some of the Linux shell types. SH is the basic one. Then that's the Borny shell. It was developed by Stephen Borny at AT&T Bell Labs. And what the describe about this Borny shell? It's a simple, lightweight shell that runs in low memory environments but has full compatibility with the Bash shell. And second one we have is CSH, uh, C shell. It was developed by Bill Joy at University of California. Then we have KSH, we call it as a corn shell. So it was developed by the David Korn at AT&T Bell Labs, and the shell, the shell named after the corn, David Korn. And it is a programming shell which is compatible with the Borny shell, but supporting advanced programming features like associative arrays and floating point arithmetics, which are not supported by the Borny shell or simple SH shell. Then we got S bash. This is by and large the default shell, and which is widely used by the many Linux administrators. So we call this shell as a Borny again shell. So it was developed by Brain Fox for the GNU project. The name is also descriptive of what it did, bashing together the features of SH, CSH, KSH. That is the reason the name also given in such a way that Borny again shell. So whatever functionality or features can be done by SH, that's Borny shell, CSH, that's C shell, Corn shell, KSH, all can be incorporated into common shell that is called Borny again shell. Then we have TCSH, that is 10x C shell. Seashell. This was developed by Ken Greer at Carnegie Mellon University, and it is a shell that incorporates elements from the C programming language into the shell scripts. And finally, we have JEDSH. It is an advanced, very advanced shell that incorporates features from Bash, TCSH, and Corn, providing advanced programming features, shared history files, and themed prompts. Then we will move on to window management software. Window management software, or simply we can call it as a window manager. So then after that we will go for the AS, that's application software. So let's here we will explore a little bit about the Linux desktop environment. Let's let's turn the clock before we explain about window management software. So if you turn the clock, if you rewind back, then only we can understand why this window management software and an application software has been added into the Linux kernel and GNU system utilities. In the early days of 19 sorry in the early days in the early days of Linux, maybe around the early 1990s, all that was available was a simple text interface. We call it as a console text interface to the Linux operating system. This this text interface is allowed administrators to start programs, control program operations, and move files around on the system. With the popularity of Microsoft Windows, computer users expected more than the old text interface to work with. This spurred a more development in the open source system community, and the Linux graphical desktop emerged. This is what the background of how this Linux window management software and then graphical desktop has emerged. So let's there it has begun with the X window system. uh, the X window system, uh, it consists of two basic elements. One controls your video environment, the video card in your PC and your monitor, and it display fancy graphics on your computer. The Linux software needs to know how to talk to both of them. The X window software is the core element in presenting graphics. Then we have the core X window software that produces a graphical display environment, and it controls how Linux applications can present fancy window and graphics on your computer. Then the core X window software produces a graphical display environment, but nothing else. Although this is fine for running individual applications, it is not useful for day-to-day computer use. So no desktop environment allows users to manipulate files or launch programs. To do that, you need a desktop environment on top of the X window system software. So there are different types of desktops are at this moment are available. So one of them is the KDE desktop. The KDE desktop was first released in 1996 as an open source project to produce a graphical desktop similar to the Microsoft Windows environment. The KDE desktop incorporates all the features you are probably familiar with if you are a Windows user. So let's go into the KDE desktop and see how does this looks. So this is how your KDE desktop looks, and the bar at the bottom here you can see this is our bar. The bar at the bottom of the desktop is called the panel. The panel consists of the following very important major parts. The first one is the K menu. The K menu, we call it as a K menu. Much like Windows, it consists of start menu. Here it is, start menu, and the K menu contains links to the start installed application. It is by and large similar to our Windows management, Windows software. And after that you will have a panel, and then the program shortcuts you can find. These are the quick links to start applications directly from the panel, and you will have a the taskbar on the rightmost. So the taskbar shows icons for the applications currently running on the desktop, and then finally you also have the applets. These are the smallest. Here you can see these are the smallest These are small applications that have an icon in the panel that often can change depending on information from this application. It's a complete replica of Windows management, Windows software, Windows graphical user interface. Here you can see this is our K menu, and then here you have a program shortcuts. This is your complete panel or bar, and this is the applets. So now let's get back to the application software section, and the next which is available in pipeline for us is the Genome Desktop. uh, the GNU Network Object Model Environment. That's what the abbreviation of GNOME. This is very famous one. The Genome Desktop is another popular Linux desktop environment, first released in 1999. Genome has become the default desktop environment for many Linux distributions. However, the most popular is Red Hat Linux. So let's look into the Genome desktop too. So this is our Genome desktop. This is how it looks, and so here Genome, the GNU Network Object Model Environment, that is our GNU. Although Genome choose to depart slightly from the standard Microsoft Window look and feel, it incorporates many features that Windows users are comfortable with. It consists of a desktop area for icons, a desktop area for icons, and a panel for, this is the panel for showing running application, and drag and drop capabilities. You will get a drag and drop capabilities too. Then one more application, one more desktop type that we have is the Unity desktop. The Unity desktop, if you are using the Ubuntu Linux distribution, you will notice that it's somewhat different from both KDE desktop and GNOME desktop environments. So because it's founded by Canonical, the company responsible for developing Ubuntu, has decided to embark on its own Linux desktop environment called Unity. So this is the single desktop environment for workstations, tables, and mobiles. It's famous for the Ubuntu. And this is how it looks. The Unity desktop gets its name from the goal of the project to provide a single desktop experience for workstations, tablet devices, and mobile devices. The Unity desktop works the same whether you're running Ubuntu on workstation or a mobile phone. So you can clearly observe various example of Unity desktop in your screen. So then what we have is an application software that we have discussed so far, which adds a graphical user interface to the window management software. So in addition to whatever we have discussed so far, uh, we will add few more. We will extend this discussion for few more graphical desktop environment that are available here. So the downside to a graphical desktop environment is that it requires a fair amount of system resources to operate properly. Example, in the early days of Linux, the hallmark and selling feature of Linux was its ability to operate on older, less powerful PCs that the newer Microsoft desktop products could not run on. However, with the popularity of KDE and Genome desktops, that has changed, because it takes just a much memory to run a KDE or Genome desktop, the latest Microsoft desktop environment. As the latest It is as similar to the latest Microsoft desktop environment. So there was a huge development that had happened on application software also. And if we extend our discussion, so the following are the few more desktop environment that are available in the market. The Flukesbox XFCE JWM. This is Joyce Window Manager, a very lightweight desktop, ideal for the low memory and low disk space environment. And FVWM and an FVWM 95. These also support some advanced desktop features such as virtual desktops and panels, but runs in low memory environments. This is what the complete details about the kernel or Linux. Linux we have discussed from the Linux kernel. Then we moved on to the then we moved on to the GNU utilities. Then we moved on to the window management software, then application software. So now it's time for the put everything together, and so we will look into various Linux distributions. Now that you have seen the four main components required for a complete Linux system, you may be wondering how you are going to get them all put together to make a Linux system. Fortunately, other peoples have already done that for you. So a complete Linux system package is called a distribution. A complete Linux system package is called a distribution. Many different Linux distributions are available to meet just about any computing requirement you could have. Most of the distributions are customized for a special user group, such as business users, multimedia enthusiasts, software developers, average home users. Each customized distribution includes the software packages required to support specialized functions. So, such as audio and video editing software for multimedia enthusiasts, or compilers and integrated development environments for software developers. So let's begin, and let's look into the each distribution that are available based on their need. So the first one what we have is a core Linux distributions. A core Linux distribution contains a kernel, one or more graphical desktop environments, and just about every Linux application that's available pre-compiled for the kernel. It provides one-stop shopping for a complete Linux installation. The famous one is Red Hat, a commercial business distribution used mainly for the internet services, mainly for the internet servers. And we have Fedora. Fedora, a spin-off from Red Hat, but designed for home use. And we have Debian. Debian is a popular with Linux experts and commercial Linux products. Then we have OpenSUSE. OpenSUSE are different distributions for business and home use. Then we have Gentoo. Gentoo is a distribution designed for advanced Linux users and containing only Linux source code. Then finally, what we have is a Slackware. Slackware, okay, yeah. Slackware, one of the original Linux distributions that sets and popular with the Linux geeks. Then the second one, what we have is a specialized or advanced Linux distributions. A new subgroup of Linux distributions has started to appear, not too long, just recently. They are typically based on one of the main distributions, but contains only a subset of applications that would make sense of specific area of use. Let's begin with CentOS. CentOS, I really like it. CentOS, so a free distribution built from the Red Hat Enterprise Linux source code. And we have Ubuntu. Ubuntu we are going to widely use in this course. Of course, CentOS also we are going to use in this course, but when we are working on Kubernetes, that time we are going to use CentOS. Even Jenkins, when we work with Jenkins, also we are going to use CentOS. So now Ubuntu, a free distribution for school and home use, and we have PC Linux OS, a free distribution for home use and office use. Then Mint, Mint, a free distribution for home entertainment use. Then we have Dynabolic. It's a free distribution designed for audio and MDA application. Then the final one is Puppy Linux. Puppy Linux. I think Puppy, it's dog's name. That's good. So a free small distribution that runs well on the older PCs. That's just a small sampling of specialized Linux distributions. These are literally hundreds of specialized Linux distributions, and more are popping up all the time on the internet. No matter what your specialty, you will probably find a Linux distribution made for you. That's why you should love Linux. Actually, I really love Linux. After I started working in corporate IT companies and other companies, I literally fell in love with Linux. More than I spent time with my girlfriend, I used to spend a lot of time with the Linux. So Linux is love for me. Okay, so now we will move on to the next one, that is the Linux Live CD, a relatively new phenomenon. It has started just few years back in the Linux world. Is the bootable Linux CD distribution. This lets you see what a Linux system is like without actually installing it. This is an excellent way to test various Linux distributions without having to mess with your PC. Just pop in a CD and boot. All the Linux software will run directly from the CD. So you can download lots of Linux live CDs from the internet and burn onto a CD to test drive it. So Nopix, a German Linux, the first Linux live CD developed. Then PC Linux OS, a full-blown Linux distribution on a live CD. Then we have Ubuntu. Ubuntu Live CD is also available, a worldwide Linux project designed for many languages. Then we have Slacks, a live Linux CD based on Slackware Linux. Then we have Papier Linux, a full featured Linux designed for older PCs. That's just a small sampling of specialized Linux distributions. It's a ocean. It's bigger than the ocean. So you will have a hell number of Linux distributions. If you want to look into that, you just go to the Wikipedia of the Linux and just search for it. So this is the Linux distribution Wikipedia page. If you just go through it, here you have your diagram. This is what I'm talking about. This big it is. Slackware Linux, just now we talked. Then you have Debian. Then what you have ahead is Red Hat. Here it is. You have a Red Hat. You have a CentOS. You have a Red Hat Enterprise, and there are hell number of distributions are available. So here you can see from 1992 till 2000, almost 2022, you are going to find all types of distributions here from CentOS, everything, almost all. So this is huge. This is fundamentally huge. So you just type Linux distros Wikipedia, just enter it and zoom it and see it's a ocean. It's an ocean. Whatever we are discussing is just a tip of a drop of uh, version. That's it. Let me put it into proper way. See, from 1992 till 2022, you can clearly see Slackware. These are all the distributions, and you can find all the distributions at a one place. Uh, just go through it. So no matter what your specialty, you'll probably find a Linux distribution for you. So here in this chapter, we have discussed the Linux system and the basics of how it works. The Linux kernel is the core of the system, controlling how memory, programs, and hardware all interact with one another. The GNU utilities are also important piece of the Linux system. The Linux shell, which is the main focus of this part of this module, uh, is the part of the GNU core utilities, and this part also discussed the final piece of your Linux system. That's the Linux desktop environment. Things have changed over the years, and Linux now supports several graphical desktop environments. So this chapter also discussed various Linux distributions. Though you can see it is on your in front of your eyes from the Wikipedia page. So your Linux distribution bundles the various parts of Linux system into a simple package that you can easily install on your PC. So the Linux distribution world consists of full-blown Linux distributions that include just about every application imaginable, as well as a specialized Linux distributions that include applications focused only on a special function. So in the next sessions or slides, you will look at what you need to start your command line and shell scripting enterprise. You will see what you need to do to get the Linux shell utility from your fancy graphical desktop environment. These days, that's not always an easy thing. So have a look at this Linux distributions from the Wikipedia.